Okay, we're going to look at Kirchhoff continued. So we've already taken a look at the loop rule. Now we're going to take a look at the junction rule. Let's begin by explaining what exactly a junction is. So let's take point A, which is a junction. So what does that mean? That means that junction, there's current going in and current going out. So as you can see, I've labeled I1, I2, and I3. So what we are going to do is come up with an equation. Well, which currents are going in to junction A? So the way this works is you know that I in, the current in, has to equal the current out. So in this case, going into junction A is current 3, I3. Coming out of that junction is two currents. I1 goes up and I2 goes down. So the current going in is I3, the current going out is I1 plus I2. So what we're going to do is we're going to take that and we're going to set that equal to 0. So we have I3 equals I1 plus I2. I'm just going to set it equal to 0, so 0 is equal to, I'm going to write 1I1 plus 1I2 minus 1I3. And that is us applying the junction rule. Now we're going to take a look at the loop rule, which we've already discussed. And we will start by taking a loop at the top loop. And we are going to go in the direction of current A, so we're just going to go around in this counterclockwise direction. So let's go through. So starting at point A, we're going to go up. We make it to the 30 ohm resistor. So the first thing we need to write is minus 30. And which current was going through the 30 ohm resistor? I1. Okay, we come over here, we make it to the battery. So we are going from negative to positive, the short side to the long side, so we have to write plus 45 volts. Now, which current is it between points A and D? Well, this is current 3 because we have a junction here and a junction here. A junction is the only point where the currents can change, right? So you'd have multiple currents flowing in or flowing out. So in this case, in this middle branch of the circuit, I1 comes in from the top, I2 comes in from the bottom, and that's what creates I3. So I3 goes through the internal resistor, so that's going to be minus 1I3 minus 40I3 because it goes through the 40 ohm resistor, and then we're back at point A, so I know that has to equal 0. So let's go ahead and simplify our equation. So I have minus 30 I1 minus 41 I3, equals negative 45. Now you'll notice there's no I2, so I'm actually going to add a line that says minus 30 I1 plus 0 I2 minus 41 I3 is negative 45. And hopefully that'll make sense in a minute here. Now you can do this a bunch of different ways for simplicity's sake, so we're all doing it the same way. We're going to pick the same loops so we have the same equation since we're learning how to do this. So what we're going to do is we're going to start at point A, and we are going to go all the way around back to point A. So starting at point A, the first thing we come to is this 30 ohm resistor. So I'm going to write minus 30 I1. Now I come down to junction D, and now I'm going to be along the current 2 branch. In this case, I'm going in the opposite direction of the current. So our current, as you can see, is going this way, but our loop is going in the opposite way. So we would normally subtract IR, but because we're going in the opposite direction of the current, we're going to add IR. So in this case, it's going to be plus 20. And which current is this in the bottom? That is I2 plus 1, because we're at this internal resistor here, I2. And now we get to the battery. Now you see we're going from positive to negative, so we're going in the opposite direction. So instead of adding 80 volts, we're actually going to subtract the 80 volts. And then that should bring us back to point A. We're going to go ahead and simplify this equation. So we have minus 30I1 plus 21I2. How many I3s do we have? Well, we have none, so I'm going to write plus 0 I3. Remember, this was equal to 0. And so that's going to equal positive 80. So why have I written it like this? Well, actually, let's go back and let's rewrite this first equation up here from the loop rule. So I'm just going to write it in the same way. So we have 1I1 plus 1I2 minus 1I3 equals 0. So essentially it's always equal to either the voltage or 0. So now they're all lined up. All these equations are lined up exactly the same. The first term, no matter which equation you're looking at, is I1. The second term, no matter which equation you're looking at, is I2. The third is I3. Oh, forgot the middle. And then is equal to a constant or the voltage. So this is always going to be the fourth thing. So what was the purpose of doing that? Well, the purpose is we can use what's called a matrix to solve the equation, and that makes it incredibly easy to solve systems of equations. Don't tell your Algebra 2 teacher. So here's what I'm going to do. I'm going to take the coefficients of each of those equations and I'm going to build a matrix. So starting with this first equation up here, we have a 1 for 1I1. We have a 1 for 1I2. We have a negative 1 for I3. And we have a 0. Okay, now from the purple equation, we have a negative 30 in the first term. We have a 0 in the I2 term. We have a negative 41 in the I3 term. And we have a negative 45. And now the orange equation, we have negative 30. We have 21 for I2. We have 0 for I3. And we have 80 for our constant term. So this is what we call a matrix. And we can solve a matrix very, very easily in your calculator. And I actually have that typed out in your packet, but we'll just go through it briefly here. So the first thing you're going to do is you're going to enter this matrix into your calculator. And the way you're going to do that is you're going to hit second matrix, which is also the x to the negative 1 button. You're going to hit the right arrow key twice till you get to where it says edit. For matrix A, you're going to press enter. And now you need to tell it the dimension. So it's always row by column. So you're going to do 3, enter, 4, enter. And that will create a matrix just like ours that has 3 rows and 4 columns. The next thing you need to do is simply type in the numbers. So for us, you're just going to type in 1, enter, 1, enter, negative 1, enter, 0, enter, negative 30, enter, 0, enter, negative 41, enter, negative 45, enter, negative 30, enter, 21, enter, 0, enter, and 80, enter. So now you're going to hit second mode to go back to the home screen. So now what you're going to do is you need to look, we're going to use this matrix to solve our system of equations. And the way we're going to do that is you're going to hit second matrix again. You're going to hit the right arrow key one time, and you're going to go down until you see R, R, E, F, or reduced row echelon form, which is a specific way you can simplify a matrix. And this will appear on your home screen. RREF left parenthesis. What you need to do now is tell it which matrix you want produced. Well, of course, we only have one matrix here, but we still have to tell it, so you need to go back to matrix. And then you'll notice now names is highlighted because we're not going to be hitting the right arrow key at all. And we'll press enter. And when you do that, matrix A should appear. And you can simply close the parenthesis and press enter. Now, what you will get here is a matrix that is in reduced row echelon form. And I will write that out here and then we'll talk about it. So this is the output of your calculator right here in this matrix. So now we need to interpret it. Well, remember, our first column was I1. Our second was I2. Our third was I3, and so on. So it turns out that I1 is this value, which means that this is current 1. Current 2 is this value. So this is current 2. And then I3 is this value. So this is actually current 3. And so you were able to solve a 3 by 3, 3 equation, 3 unknowns system of equations in seconds using the reduced row echelon form of a matrix. So this is an extremely efficient way of solving systems of equations. So now what we need to do is interpret our system of equations. So you'll notice that our I1 was negative. And if it's negative, it simply means that it doesn't match the way it was drawn on the picture. So I1 is negative. Let's go up and look at our picture. We said in our picture that I1 was drawn clockwise. Because we have a negative output, that is in fact wrong. So I1, the number is correct, is 0.858 amps, but it is in fact not clockwise, but counterclockwise. Okay. For current number 2, we got a positive number, which means it matches the way the picture was drawn. And current number 2 was drawn counterclockwise, so that is in fact correct. So we're going to write that 2.58 amps, and that is counterclockwise. And then current 3, in this case, it's just moving to the left. It was positive, so we will put 1.725 amps, and I'm just going to put to the left. And there you have it. We have used a system of equations and matrices to figure out what the current was in every part of this circuit. So that is a very useful application of the junction rule and the loop rule for Kirchhoff. Please refer to your packet for more specifics on the matrix commands in your calculator if you need further clarification.